Welcome back to another Silicon Labs Talking Tech podcast. This is our second episode where we're going to focus on security. On our last episode, we talked about how we're going to, on a monthly basis, provide a deeper look into some of these, relevant and current security topics. We have our security system engineers joining us again, Joshua and Arash. Thanks again for joining.
Glad to be here.
Thanks for having us again. Well,
Yeah. As we mentioned in the last podcast, the topic that you guys have really spent a lot of time on recently is on glitching debug ports. And so you guys have some information to share with our listeners and maybe help them understand why it's important, why it's happening.
Yep, absolutely.
All right. Well, why don't we just kick it right off? We've seen a lot of news articles recently about glitching attacks on debug ports. I know I've seen a few. I don't know if we want to name any names, but there are products and there are parts out there that are being accessed through the debug ports. Can you talk a little bit more about exactly what's happening and why people should be aware and concerned of this?
Absolutely. And you're right. This is something that over the last maybe 6 months has become a bigger and bigger issue and a little more publicized. A fault injection attack, to start off with, is a fancy way of saying we're going to do something to the device to get it to make a mistake. And this is typically something physical. So we are going to disturb its power supply, or we are going to have a small localized EMP that gets the device to malfunction. And that malfunction is going to benefit the attacker in some way. When it comes to Debug Lock, fault injection is a good way to attack it. For the most part, any device you get is going to work in the same fundamental way. Somewhere in non-volatile memory, there are data bits that tell the part whether it should be locked or not. So the part will come with those bits saying it should be unlocked. You can develop, you can do, program your application, and then you change those bits to say, hey, this should be locked. Every time that part starts up, a state machine, either in software or in hardware, will go look at those bits and then put the debug lock in the state it's supposed to be in. Obviously, if I can get that state machine to mess up, then I might end up with a part that's supposed to be locked, but in fact is not locked. So the most obvious and classic example of that would be if I have a bit in Flash, and if it's 0, the part is supposed to be locked, and if it's 1, the part is supposed to be unlocked, right? And my state machine is just, I copy that bit into a register that controls the lock. Then if I, let's say, EMP the part while Flash is being read, I might get a wrong answer, right? That bit that is actually a 0 saying I'm supposed to be locked might be a 1, and that part will be unlocked. So as an attacker, I can take a product that I don't have access to. I can do a little bit of work to EMP it, and now I have access to it. And maybe I can dump out the Flash contents, or maybe I can program it to do something else. So that is the general idea behind what this attack is doing and what it's attempting to achieve.
All right, that sounds like, how many devices are susceptible to this? Is this pretty common? How do people determine if their part is susceptible to this attack, or what can they do?
This is very common. Even a year or two ago, this was not something that was really important in the industry. People were aware that this was a thing that could happen, but I would say most of the industry was in a position of it wasn't something they wanted to spend money or time or attention on. And that has changed over the last couple of years. There are still a lot of people who have products where they don't care, but it's being more and more of an issue. And obviously in the news, it's more and more of an issue. That means that parts that were designed back then weren't thinking about this. They assumed that if the logic was built to do a thing, that's what happened, and didn't go out of their way to put protections for that in. So my default assumption is that any product that is not explicitly saying they are resistant to, fault injection attacks on their debug port aren't, which is probably any device that came out more than a year or two ago. Now, that's not the whole story. There are a lot of different ways to implement this, and some of them provide incidental protection. I'll give you an example of that. In our simple case, I had a single bit in Flash that told me whether I was locked, and I wrote it to a register. Well, maybe when I was implementing that, instead of having a single bit, I had 8 bits, and one value meant unlocked and every other value meant unlocked. So I've got, 255 values that mean I'm locked and one that means I'm unlocked. Well, in that case, when I get that read of Flash to be corrupted, I probably have now a 1 in 255 chance of getting the value that says unlocked. So, if I have 2 devices, one implemented the simple way and one implemented the more complex way, they might have different levels of resistance. They're probably both susceptible at some level, but they could be different. Unfortunately, it's very difficult to have any insight into, how resistant a particular product is unless you're the person that designed it and you did a very thorough analysis of what's going on there. And even in some cases, you would really want to test it because those analyses can be hard to do and can be easy to make mistakes on. So, my recommendation would be assume that you have no protection unless you are specifically told that you do. And then, if you assume you have no protection, you can always go ask the question, go ask your vendor, I am concerned about this. How resistant to this type of attack do you expect the debug lock to be?
Yeah, you gave a great example of some way somebody could mitigate the lack of security in a part, but that's probably rare, right? I mean, as you said, a lot of people didn't think of this, 4 years ago, and there's a lot of products out there. So what do those people think of? Do they have to immediately get worried and start updating their products? What's the time frame for these people with products to redesign and put in a part that doesn't have this glitchy debug port?
Yeah, this is going to depend a lot on the application the part is used in. Keep in mind that this is a physical attack, right? I have to have a part on my desk and I have to have some equipment next to it in order to make this happen. So as an example, if I'm designing a product that only exists on, industrial assembly lines that are restricted access, maybe I make the case that attackers aren't ever going to have physical access to that anyway. So this is of less concern for me. Or maybe I have a product where the code, there's nothing in the device that's particularly secret. I don't really care if the code gets out. No one can really do anything with this device, right? It's not particularly important to me. I can make the case that it's not something I need to worry about. Remember, security isn't the absence of risk, it's the absence of unacceptable risk. Unacceptable risk for a door lock looks very different from unacceptable risk for a fan that you plug into USB and it spins, right? Those are very 2 different things, and you probably don't care at all on the fan, and you probably care a lot on the door lock. So that's the type of analysis that needs to go on. And the 2 defining characteristics of this attack are A, it's a physical attack. So someone has to be physically present, and it's not a particularly quiet one. I can't walk up to a product and like touch a couple of leads to a header and then this happens. This is like I roll up my cart with my EMP or my big power supply and I like do some connection stuff. So this is not only a physical attack, this is probably more of a laboratory physical attack, or in a situation where you can get some reasonable amount of time with the product in the field. The other thing is this is likely transient. If you are already using something like Secure Boot, this will let somebody get into the product, but when that product gets reset, it's going to redo Secure Boot. So like editing the product would probably be pretty difficult. So you have to think about what people want to, actually do.
So a couple things too to add. sometimes a device that you have attackers targeting isn't one that would directly affect that particular end user. There are instances for vendor provided hardware where there is a key or set of keys they use to validate their firmware or something that is private to access on their network, that an attacker, by glitching open the debug port, can dump the firmware, can extract keys, can figure out a lot of stuff about the system in order to then get themselves prepared for a more sophisticated attack across all of those devices that have been deployed, especially if those are a set of credentials that are reused. So in that case, yeah, you could really end up in a so there are instances where you may not see it directly, but then you have to think about that whole system, and then you understand better.
That's a very good point. And I would go so far as to say, if your device is a participant on a network, then you really don't have the I don't have any secrets card to play in that particular case. The other thing in that same sort of line of thought is we do need to be aware that sometimes the thing an attacker is trying to get with this style of attack is information to make a better attack. So for example, I might get a copy of a product and glitch the debug port open so I can see its code, which will make finding an over-the-air exploit easier. So you do have to consider that aspect as well. Again, it's very system dependent, and every product is different, and every company is a little different in what their needs are. But those are the factors that you want to think through. And I also think it's important to realize, you're not alone in this. If you're using companies from products and you're not quite sure of your evaluation, you should be able to ask them for an opinion. So for example, people who are using our products and aren't quite sure how to make this value judgment, they can come to us and we can help look at their system and give our opinion on what we would recommend that they do. And really anybody that's doing microcontrollers should be at a point where they can do that. That's something you want to look for in a vendor. You want to have, we're partners, we're building a system together. That's always the case. Security is a system level problem. And so, you want to make sure you're comfortable that the vendors you're working with are sort of on the same page with respect to security and can give good and valuable opinions.
Well, this has been great. You guys went deep. You truly are the security system engineers. I thought maybe that wasn't true, but yeah, you guys have a lot of great information to share with our listeners. So I'm sure they learned quite a bit. So what do you guys have in stake for us in the future? What are some of the topics that you guys are thinking about for future security podcasts?
We've got a list of ideas. I mean, I get up every morning and read news, and usually every day there's one more thing that pops up that can be a topic on here. But I think we'll see where things go. What you're interested in, what the audience is interested in. I'm sure they can send us emails if they're clamoring for a particular topic to be discussed that they're particularly interested in. So
I think recently there was a little bit more public exposure to an IoT related flaw. I was watching John Oliver's segment, and he talked about certain devices that could have been compromised. There's a lot of kitschy devices out there that are being released that don't have they have extra features that probably they shouldn't have. And so I think that the conversation about what as a concept in security, what the minimum access required should be, or least privilege principle, right? Some of these don't need to be internet connected probably, or some of these things could use a different way for control. So I think that would be an interesting topic we could revisit as like a systems level sort of discussion of what kind of products probably should or could be shored up, or we could improve on as far as for security reasons. Yeah.
All right. Well, let's start planning for it, because we'll definitely have a security podcast in a month, and I'm looking forward to what you guys bring to the table, and I know our listeners will as well. So thanks, guys, for the time. I know glitching security debug ports might not be the top of mind, but I think after listening to this podcast, people have a better understanding of what it is, why it's occurring, and things that customers need to do to address it and why they should address it. So thanks for taking the time.
Yeah, thanks for having us. It's been fun.
All right. And again, to our listeners, thanks for taking the time to download our podcast. We hope you enjoy the security segments that we're putting together. And until next time, everyone, take care.